The first part is to extract the centroid files from the PC board layout. You do this by selecting Tools, Reports, then you go and find the report that you want. I've created a report here called Orcad to TM. We open it. That is the text file that describes the report. If you then run the report, you'll notice that you get a list of all your components, the value, the center X and center Y, and you can see these are in mils, which is thousandths of an inch, not millimeters, whether the symbol or the part is rotated or not, and what the package is. That is the report that is made by the Allegro system. You want to obviously save this report, so you go again, you select this report, and you say you want to write a report file. So let's call it board 27B. And then when you click on here, write report, and you say report, it tells you one report has been written. You close this down, and that is the end of step 1. The next thing that we have to do is run this utility called Orcad to Visual Place Converter. So we select read. We then go and find the file that we made, which is called board 27B. We select that and open that report file. And you'll notice here, here's the information that was generated in the last step. We now want to convert from inches to millimeters, so this box must be ticked, and we say convert. It's now converted all the dimensions from inches, the X and Y, from inches to millimeters, and also put it in the correct format for the next step in the process. So now we have to write this converted file out, so we say write, and we'll call it board 27C. And it's a comma separated value file, which we save. We replace the old one, and that step is now done. That's step 2. For step 3, we run a program called Visual Place, which is downloadable off the net. The first step is to say file, new, project. We now want to get the centroid files, which we made in the last step, so we click over here, and we go and look for board 27C, which is our centroid file, and we open it, say OK. We then give this project a name, so we can call it ABB, save it. And now you get a list of all the components. Here's your components, the quantity of them on the board, the package, and the reference designator for the component. We want to write this list out into a format suitable for the TM220 pick and place machine. To do that, you say File, Export, Centroid Files. We give it a name, and we'll call it board 27D. I just use A, B, C, and D so I can follow the steps in the sequence. And it's important here that the format we want to save it in, you select here TM220A and say save it. What happens now is a dialog box pops up with the components in the feeder. So I'm just going to backspace here to clear this out so we can follow the sequence correctly. These numbers are the feeders. Feeder 0s for ICs, and these are for tape reels, feeder 1, 2, 3, up to 15 on the pick and place machine. This is the placement height, the thickness of the part. This is the feed rate in millimeters, so you'll see it's 4 millimeters per step. If you want to adjust the X and Y or the rotation and which head you want to use on the pick and place machine. So what I do is I go here and I say, okay, we've got 28 of these components. So in the first feeder, I want to put the 100 nanofarad capacitors. That's it, and you can see there's the reference designators. You then go to the second feeder and you want to take, let's say, these 4.7 ohm resistors. So you go down and you look for the 4.7 ohm resistors, which are there. The next one we want to do is perhaps the 1K. So there's 12 of them. So we go to the 1K resistor. That will be down here. There's the 1K resistor. Then we'd like to have the 10K resistors, of which there are 21. So we'll go down here and select the 10K resistors. And that looks like it for high volume or high count parts. So let's maybe put these resistors here, these 1 ohms, there's 4 of them. So we'll go and get the 1 ohm resistors. We'll take the 12 ohm resistors, which there's 4 of. We'll take the 49.9 ohm resistors, which there's 4 of. And we'll take the 75 ohm resistors, which there's 4 of. This would then be how you would load the machine. So you'd make sure that you had these components in these relative tray feeders, or real feeders, should I say. Once you've done all of that, you just want to write the file. So you say, OK, and it says centroid file has been saved. And here you can see the output of board 27D. It set up the machine with the stacks, with the offset. It's got your feeder rates. There's that 4 millimeters that you saw for stack 1 to 15. And as you scroll through the file, you'll see that here's component 1. It tells you the XY coordinates, which have been converted to millimeters correctly. There's the reference designator. There's the comment. If you don't want to place the component, you can edit this and put skip as a 1, and then the machine won't try and place it. And this is the file that you save onto the SD memory card that you place into the pick and place machine to run your job.